DROACOR. This is our new product for Micasense processing of reflectance imagery. Developer from Resi Applications, and I'm going to show you how to perform an in-flight calibration for the Micasense sensor with DROACOR. In-flight calibration is required once in a while to get your sensor parameters correctly, such that you can do a fully automatic reflectance retrieval later on. And in-flight calibration is typically done based on a reference panel. So you have to first find your imagery containing the reference panel and a good reference image of your site to get image statistics. So these two data sets have to be provided at first or put to the side together such that you can do the in-flight calibration based on this reference imagery. Then you get to import the data first. So importing the data is done through Micasense import, and you first select the directory of the data with the reference panel. Here is the data with the reference panel, and I get one data set with reference panel in here. Okay, and it found one data set based on this filter. You don't need a calibration file yet because you want to find it, and you may already know the ground altitude, which is in a range of about 530 meters here, and we could also use global elevation model. That's a little bit less accurate. If you already know it, that's better. Now we want to co-align the data during the import, so we have to create a camera file. So we use this import file and define a camera file name for it, and I call it just camera panel, and it will now create a camera file. So this is a correlation file between the 5 bands to co-align them into one image. So this is done now, and we have this cam panel. We have to select it again, cam panel.sav, that's that one. And so we can now create this integrated file. I'm putting it to a different directory, like here, and it will create this single file there. It's usual this panel is built for multi-file processing, but you can also use it for single files. You just have to adjust the filter accordingly and push the apply button, then you will have only one file to process. So now I'm importing that, and it will import one file. That's done now, and I can have a look at it. That's this image file, RGB, and this is the imported panel data file, and you could even read the panel reflectances here on this label, and we will use them for calibration now. Moreover, we also need to import a file of your scenes. So I'm importing just a little set of scenes here. So I got 10 files here, and I'm importing all of them, and one of them will be used later as a reference image for background statistics. So this is also imported. I have to do the same game again. So I'm using a camera file. So I create a camera file, calibrate it, and so on. I don't do it again. It has been done before. But you have to do a second calibration if you are at a higher flight altitude. So the geometric camera calibration is good for the standard flight altitude. If you're very close to the panel, you have to create a different file. This is due to the distance between the individual sensors. So this is now the output, putting it here, and I'm importing this data as well. This is quite a fast step. It will already write all the metadata for this data from the TIFF file, such that you can use it later for the processing. So now we are ready. We imported the panel data and we imported the image data. We are ready for the in-flight calibration. I go to DROACOR in-flight calibration because I only have one panel. Usually with Micasense, I'm using this process. And for this process, I need the panel data. The panel data is given here, in here, the one I imported just now. And I can show the image. And so here it is. And I'm going to the panel. I do push position to get the position right. I can select the get position to get a panel position. I'm using a larger window such that better statistics are taken from the panel, and I can define the panel reflectances. So I already defined them beforehand, so they can be found here. But you could also define them manually for the 5 bands. These are the numbers which are also printed on the label of Micasense for the 5 bands. Done. So I can select this panel reflectance library. I can plot it. So this is 50%, that's correct. And now I need the adjacency reference file. This is the one from the standard scene. So that's not in the panel, that's this one, this image. And based on these 2 images, the panel from the panel image and the adjacency image, I can create a calibration file, which is named, let's just call it panel.cal. Okay. So this is, I can perform the calibration, and I can plot the calibration data. So this is the outcome of this process. So originally it was no offset, but after the calibration it tells me that there is some offsets. And on the other hand, for the gain, that's also quite a little bit of a difference against the standard calibration. So we updated the calibration now, or we have a new calibration file. The standard calibration is given by the specification of Micasense, but often these specifications are not accurate enough for a reflectance retrieval. So now we have the calibration file, and we can now import the data based on this calibration file. Going further on, I go to Micasense and I import the same data again I imported before. So I go back to the scene data. These are the 10 image scenes or 11 image scenes. I'm now selecting the calibration file we just created. That it was here, panel cal. Reference image is okay. I'm using a global elevation model, or I can use the constant, about 500 meters. And I'm using the camera file I created before, so this can be applied to all these images. And I'm writing the outputs to this reflectance thing, and I can import it now. It imports all the 11 now with the new updated calibration. Okay, so that's done. And so I'm ready for the processing based on this calibration. So I can even run the reflectance processor. So I go to this reflectance process. I'm using the output directory of before with these images which have been imported. And I'm just creating a reflectance output. I don't do any cloud removal this time. And I'm running DROACOR. And this will create now 5 images, and you see in the printout the calibration data which has been taken from the calibration file. Okay, this makes 11 files processed, so we are already done with the reflectance retrieval. So this was how to perform an in-flight calibration from Micasense imagery using a panel reference spectrum. And This data now can be used for further processing of Micasense imagery, including mosaicing using Agisoft Metashape. This will be shown in a different video available from the same location. Thank you very much for your attention, and please don't hesitate us on reezyapps.com for further information. So my name is Daniel Schläpfer. Goodbye.